Hello, I'm Dr. Martin Burke. I work in the Department of Electronic and Electrical Engineering here in Trinity College.
Hi, I'm Carol O'Sullivan. I'm Professor of Visual Computing at Trinity College and I am the head of the School of Computer Science and Statistics.
Electronic engineering now does pervade everything we see around us. It's in our homes on a vast scale, it's in our mobile phones, it's in our televisions, in our DVD players, and it's in disguise in a lot of things that we take for granted now that are in our homes too, like toasters and washing machines and fridges, all rely on the electronic instrumentation.
Yeah, I think our lives are becoming increasingly intertwined with the digital world, so interactions between the physical world and the virtual world are becoming more common. You can think of many different experiences where your digital phone, for example, is helping to enhance your daily life, and the computer graphics is now not only used in computer games and entertainment, it's also used to help the elderly, for example. It's used to enhance the business activities, and therefore I think it's for, especially when you talk about augmented reality, where you overlay virtual graphical elements in the real world, you can see that kind of new interaction where there's this seamless blending between the physical world and the virtual world is becoming increasingly ubiquitous. So I studied mathematics in Trinity many years ago, and I studied pure maths, but as part of my degree we also took a lot of courses in computer science, and I had never actually considered doing anything with computers at that stage.
Well, I was terrible at history and geography and anything like that, so I did all the science subjects. So I did chemistry, physics and biology, and I think I made the right choice. I went into electronic and communication engineering from the beginning. I was sure that that was what I wanted to do. I didn't have to make my mind up between civil, mechanical, electronic. I knew I wanted to do electronic engineering.
I think what I really like about computer science is the problem solving aspect of it. So you can really look at a problem, think through the steps logically. I think mathematics helped a bit, but also that problem solving thinking I think helped a lot. And I also really enjoyed English and science in school as well, and I think those aspects also set me up to be able to understand many of the more complex concepts that you learn in computer science.
I found the Lord through going to church and reading the Bible. So when I became a Christian, I asked the Lord to show me what I should use electronic engineering for, because it was a hard question to wonder what I should do. And the Lord led me to bioengineering so that I could help others and help the health service and be able to use it to improve people's lives and to help save lives. And that's what led me into biomedical engineering. My area of research is in non-invasive measurements in bioengineering, such as blood pressure, heart rate, ECG, and the use of electronic circuitry for that.
In particular, I'm working on these kind of physical interactions with the virtual world in augmented reality in particular. So how do we interact with physical and virtual objects that are still in the real world? So if you may be familiar with the phone game Pokemon Go, where you can go around with your mobile phone and there's a virtual Pokemon overlaid on the physical world. But what I'm interested in how to make that even more seamless.
My specialty at the moment is non-invasive measurements, but in particular dry electrode ECG recording, and we aim to get diagnostic quality of ECG from dry electrode recording, which is still a holy grail in the area of ECG recording.
The most fun parts of my career to date was I went over to Los Angeles and I worked for Disney Research and Development. So there we worked with the animation studios, but also the parks and resorts. So Disney's very into creating interactive experiences, engaging experiences. So that brought together my interest in human interaction and human perception, and also the technical aspects of computer graphics, virtual reality, human-computer interaction, augmented reality.
We have only recently begun to find some of the characteristics needed of the electronic amplifiers, and we've been able to do some relatively complex mathematical analysis of the problem to determine the requirements of the amplifier so that we can get diagnostic quality ECG.
I worked with Pixar on looking at what people pay attention to when they're watching a movie, for example, and I worked with the parks and resorts to see what people do when they're walking around a park, how they interact with the attractions, how they respond to the kind of interactive experiences that they're involved in. And my studies in computer science and my research in the interactions between humans and computer graphics and virtual environments really helped me to do that.